y equals 40?
Top angle there.
This one?
Where C is 100.
You did vertical angles are 100? Okay. So then because this is 100, this is 40, that's 140, we have 40 degrees left. Now y equals 40. That was the easier one to find, right? X is harder? X is a lot harder?
Well, you have to open your eyes more.
Okay. So I won't pick on Brandon because he was gone yesterday for this. Casey, what'd you do for X? You didn't get X? Did you try anything to get X?
I put X equals line EC, but I don't think that's right.
X equals right here?
Yeah.
Yeah. But I want a number. What do you think we would do to get a number? No idea? Want to phone a friend?
Props.
You, for X, you gotta like take away triangle BCD. So then you're left with triangle AEB. And since all angles are congruent, that means all sides are congruent. And then X plus X equals 10, so that means 5 plus 5 equals 10.
Yep. So all three, this makes one big triangle. All three angles are the same. What we learned yesterday, if you have an equilateral or equiangular triangle, it means it's equilateral. So now this side's 10, means this side's 10, it means AB is 10. So we get 2x equals 10. Divide both sides by 2. X equals 5. 5 plus 5 is do the same thing. We're going back to triangles where you have extra stuff. You have to look at little pieces of information. So it's not enough to say, okay, well, that's 10 and that's 100. I don't know. You got to use a little bit of strategy. Think a little bit harder. It's not always going to be, here's this one triangle and 2 side lengths. 5 to the third side length. Okay. Anybody have any questions from the homework? No, at least 3 of you did. Rounds you struggle with. Now's the time to ask. Checking homework, I saw 3 or 4 of you, you're like, I didn't know how to do this one. Okay. When I ask for questions, it'll be a good time to ask, and we'll go through it together. I know someone had questions. More than one person. And they all had questions on the same problems. What were those problems? Haley.
17. Number
17. It's okay if I use the worksheet. Number 17. So we had an ugly looking thing like this, where this was a right angle, this was 118 degrees, this was angle 2, and measure of angle 2 is 12x plus 4. We want to find x, correct? So, we know this is 90 degrees because it's a right angle, it's what little square means. We're going to need to use it at some point, okay? So, let's see if the person I grabbed got this one done. Lauren Rossman.
Nope.
Can you get this one?
Nope.
Lauren Shea.
The answer.
How did you do this? Give me like the first step.
I got the inside angle. Yeah, that.
This one?
62.
How'd you get 62?
And then I subtracted 118 from 180.
Right? These two angles make a linear pair. So add up to 180 degrees. So this one's 62, that one.
You still?
I get, yeah, you get one more.
Okay. except for the side down from it. Yeah, that angle is 62,
Why?
because the base angles are the same.
Yeah, base angles are the same in isosceles triangles, so those two have to be 62 degrees. Okay? Next step. No, she's not here. 80. What did you add? So we have measure of angle 2 is 12x plus 4. What did you do? Right here. What did you do? You made this one 62? Or this one 62? Why is this one 62? What does this thing tell us? 90 degrees. This one was 62, so how big is this one? 30. Close. What the other? 28. That's a terrible two. Okay, 28 plus 62 adds up to 90 degrees. That make sense? Yes? No? Question? Preston, what do you do next?
The rectangle across from it. No, that.
Yeah.
28 degrees also.
Why?
Because they're great angles.
Yeah, they're base angles of an isosceles triangle, so they have to be congruent. We're almost done. What does measure of angle 2 equal, other than 12x plus 4? Up high. We had what? Right. We're looking at this triangle right here right now. An isosceles triangle. How many degrees are left? Oh, we have 28 here and here. How many degrees are in a triangle? How many degrees are in a triangle on the inside? All of them? 180. How many do we have so far? Use your calculator. We've used 56, right? So how many are left inside that triangle? How many are inside of a triangle? 180. How many did we use already? 56. 180 minus 56. 124. Right? Did I do that right? Okay. Next step. Marissa. Why is 12x plus 4 equal to 124? So what property did you use? You can use substitution. There's a better one than I was thinking of. Substitution works since it's equal. What other one is there? A equals B, B equals C. Transitive property, right? So we just go through Solve for x. Subtract 4 from both sides, so we get 12x equals 120. Divide by 12. X equals 10. Okay? There are a few more questions similar to that on the back that people struggle with, but it's the same process of, okay, I know this angle, so let's worry about the angle right next to it, or the vertical angle. And because of that, we're inside of an isosceles triangle, base angles are congruent. So you slowly build your way across the picture. Okay? Any other quick questions on the homework, or we can get into new stuff today? New stuff. I promise that these things are going to be harder today than yesterday. Everyone likes that, right? Take that silence as a yes. That you're all super excited. Okay, so we're going to talk about mid-segments of a triangle. Mid-segment. What does that sound like? Anybody? Anybody?
Midpoint.
Sounds like a midpoint. And what else?
Bisector. Well, in the way.
No. Midpoint, that's what the mid part is. What was that, Aiden? Segment. You have a midpoint and you have a segment. It is the segment connecting two midpoints of a triangle. So that would be an example of a mid-segment if I labeled this D and E. You find the midpoint at one side, find the midpoint on the other side, connect those dots. That's your mid-segment.
So you could say like AB is congruent to
If it's isosceles.
DB. Yes.
Yeah. So, we know for sure, it does not matter what triangle it is. These are congruent, and those are congruent. If it's isosceles, these things are congruent also.
Oh.
If this looks like an isosceles triangle, but what do we know about pictures in math class?
They do not know.
They're not always drawn to scale. Okay? Oh, you missed out on the fun stuff already. So I'm going to take this down super quick. Is this easy so far? Did I scare you yesterday when I said today was going to be harder?
No.
I was trying to. It'll be a little bit more difficult. That's just a basic definition. Now we're going to get into some fun things with fractions. How much do you guys like fractions? You hate them? Fractions are fun. Fractions are fun. They make the world go round. Got it? Okay. We have our mid-segment theorem. Okay? Mid-segment theorem. So I'm going to use this, I'll use DE as a mid-segment. It applies for all mid-segments. The mid-segment of a triangle is half the length of the opposite side. And when I say opposite side, I mean, here's the mid-segment, there's the opposite side. Okay? And they are parallel. So, this is parallel to that, and the length of DE equals 1/2 the length of BC. Now it's important that when you solve problems you put the fraction at the right segment, because if I said that BC equals half the length of DE, does that make any sense? No. It's further up into the triangle. This has got to be smaller. So make sure your fraction goes with the right segment. It's one of those little tiny errors that some people make, where they're just like, okay, I can do this, fractions are easy, whatever. They start going to town and they don't realize what they wrote down right away. So they did all their math correctly, but they set it up wrong to start with. Okay? Does this make sense? Or at least have some sort of understanding? Question?
No, next.
I thought your hand was going up.
Well, yeah, next.
The cards are flying. Should have known that. Okay? U, V, and W are all midpoints. So that means RU and US are congruent. RV and VT are congruent. SW and WT are congruent. Okay? It's standard practice. Given information, mark it on your picture. ST has a length of 90 inches. VW has a length of 57 inches. We want to find the length of RS and the length of UV. First person card gets chosen. You get to pick RS or UV, so you're the lucky one. Sammy, which one do you want to work with? Okay, you want to work with UV. What does UV equal? It's a mid-segment. Look back at your mid-segment theorem. What does it say? Half the length of the opposite side. So you pick UV, color that in red. Where's the opposite side? The whole side. Whole side. That's to what? That's the T. This is the whole side. So UV equals half of ST. Don't we know what ST is? Yeah, what is ST? Mind you. Okay? So we get the UV equals how many inches? 45 inches. Okay. Well, type of person, you're smart with RS. Get the hard one. Peyton.
Wouldn't US be 57, so then RS would be 114?
Yeah. You got there without even drawing on the picture. You say, we're still looking at VW. Where's our opposite side?
US.
RS. It's the whole side. Peyton said that VW is equal to US. It is. Just because this equals the half the length of this, and that's a midpoint, so it's half that whole length anyways. So she multiplied it by 2, right? So our equation, I'll write it in black now since I don't have the color, is going to be that VW equals 1/2 of RS. Well, we already know VW, we don't know RS, so we multiply both sides by 2. We get 2VW equals RS. VW is 57. So that's how we get the RS is 114 inches. Any questions on that one? No? Cool. Alright. I want to talk about using variable coordinates. This is going to be something that you really like. How many of you love the distance formula? How many of you wish you never had to use the distance formula ever? That one I believe more. Okay? What's the easiest way to find the distance?
Y, 2 minus.
That's the distance formula, is what you're trying to say, but what's the easiest way to find the distance? Have it be straight across, or straight up and down, or the same x or the same y, so the change in x or the change in y is the same. Like if you have 0, 0, and 2, 0, how far away is that? 2, because the y's didn't change at all. But if I had 0, 0, 2, 1, then you have to do a bunch of stuff with the distance formula, right? You can't just count over. That's what we're going to do here, is try to eliminate that. So we're going to place a rectangle on the coordinate plane to find the side lengths. The easiest way to find side lengths is to have them straight across or straight up and down. So I'm going to always pick this quadrant. You can pick whichever one you want, but everything's positive in this quadrant. So I'm going to work there. Right? Negative numbers aren't as fun to work with. So I'm going to draw a rectangle right here. Okay? I'm going to make sure that it's on the lines. So that's going to make it even easier to work with. If it's a little bit off the line, you can still do it, but it makes it a little more frustrating. So what is the coordinate at this point? 0, 0. That's going to be the only one that has actual numbers for both coordinates. Okay? We don't know how tall this rectangle is. We know the x part is 0 here. So what variable should we have it for how tall it is? Let's not use x or y because x and y coordinates. A, okay? This rectangle is A units tall. Okay? So our height, our side length here is A. What do we know about this side length? It's going to be the same, it's a rectangle. So it's also going to be A. What about this one? What coordinate is 0 here?
The x coordinate, or y coordinate.
The y coordinate.
And then x would be there.
This is a variable. What variable should we pick this time?
B.
Is it a P or a B?
B.
B? You just want to just say BL.
No, just A.
So we know that this side length is what?
B.
B. This one?
B.
What about this coordinate right here?
It's going to be B0. Or BA,
It's
yeah.
going to be BA. So we can pick whatever coordinates we want. Okay? This will be true for every rectangle. If we make this 15 and B 12, that'll still work out just fine. Okay? We'll do something with a triangle a little bit that's going to be a little bit different. Okay? This works out perfectly for rectangles. Pick a variable, you're golden. We'll go to a triangle. First off, how many different triangles can we come up with sidewise?
Well, there's
Sidewise. There's scaling, isosceles, equilateral. What about by angles? Obtuse, acute, right, and equiangular. Which is going to be the easiest to put here?
Isosceles.
The right triangle would be easiest because you
Oh, I
just
suppose, yeah.
do this, right? That'd be the easiest one. We're going to be super generic though. Equilateral, maybe, but I'm going to be even more obnoxious. I'm going to put one right here, put a dot here, a dot all the way over here. I have no idea what these side lengths are. Okay? But we do know this point. What is this point? 0, 0. We know the y coordinate over here is 0. But instead of picking one letter, I'm going to have it be 2 of one letter. So last time we picked B, so we'll use different letters this time. So this time I'm going to use S. I'm going to put it as 2S. Right? S can be any number we want, so we can have it be 2 times it. Works just fine, right? What about this top point, the vertex?
It's going to be SS and then other variable.
can't be S. What's that? Because this point, I could have drawn it so that this point was right here, over here, up here. So it's not going to be 1/2 S. It cannot be S. S is one letter you cannot pick
Okay,
now.
YY is easy, no, because that's YX, or RROO,
Okay? I like 2R.
or, okay, that works.
And I won't use O because we use 0. I just don't want to get O's and zeros confused.
T's.
So I'll use T's. 2T. So what is the, I'll try to make this S look like an S, not a 5. What is the length of this base? 2S. We went from 0, 0 to 2S, 0. That one's easy to find. The other ones on the rectangle will be like, okay, I found this. Let's go to the other one. Triangle doesn't work that way. Right? We're going to have to use the distance formula. So what is the distance from here to here?
2R.
It's 2R. We moved over and we moved up. So what is our distance formula? Let's write that down real quick.
D equals
Square root.
1 plus, yes, square plus,
Okay, that's our distance formula. We have to start with handy dandy zeros. So that's going to be really nice. Okay? So what is this distance going to be? It's going to be 2R minus 0 squared plus 2T minus 0 squared. The square root of that. So the square root of 2R squared plus 2T squared. Okay? That's easy. We can't solve this for numbers right now because we don't know what any of those letters equal.
You can put any numbers in for these letters.
Any numbers will work as long as they make a chunk. Okay, what about this side length?
Like this, no, it would be the same.
It would be the same.
It would be 2S, the square root of 2S plus the square root of 2T.
Here's our distance formula. This one gets uglier, so I'm going to have a little scratch work down here. So that one is going to be the square root. X2 minus X1, which one do you want to be X2? Heck, this one again. So we'll do 2R minus 2S squared plus 2T minus 0 squared. Okay? Actually, there's not really scratch work, but it's a lot larger. So this is that side length.
Why do you use T as a 0?
What's that?
Why do you use T?
Because we're looking at this side length. We did X2, Y2, and X1, Y1. X2 minus X1 is 2R minus 2S.
Yeah, that makes sense.
Y2 minus Y1
is 2, got it.
that minus 0. I just left it. That kind of makes sense?
Yes.
It's a little bit different than what you're normally used to thinking of, right? A little bit?
Seems easy,
I don't know if it seems easier, but it seems very useful. Because you don't have to use the distance formula every single time, right? If I gave you a question and said, what is the side length of this rectangle with these points? You're like, okay, well I have to just do all of this, and I don't really want to.
No, we just draw it out.
Now you just draw it out. Okay? Make this correction.
B.
I don't know how or why, but on your notes, that's an M. It's hard to prove stuff about a DE if you don't have a DE in your picture. Right? Now we can use the strategy that we just talked about to prove this. So we're given that DE is a midsegment of triangle OBC. Since it's a midsegment, we know this is congruent, and we know that is congruent. Okay? We want to prove that these are parallel, this is half the size of that.
Would you say DE is from 1 to DE?
So this is going to be completely different than all the proofs that we've done before. Okay? Normally we've done the statement, reason, write out everything. That'd be a lot of extra writing on here. Okay? So we're not going to do that sort of proof right now. If you wrote that, that's fine. It's not wrong. But I figured you'd rather erase now than after we go through a bunch of stuff. Right? So I can put this in a coordinate plane. Just like this. What is this coordinate? 0, 0. What is this one? Where's C at? Where? It's 0 in the Y. What about the X? What do we do on the last page? What do we do for our triangle now? Put a variable, we put 2 times a variable, right? So I'll do 2s again. Just keep it the same. What was our point for B? 2r, 2t. Okay. Apparently I can't hold on to this thing today. Do we want to try to prove they're parallel first, or that the bid segment's equal to half the opposite side? Parallel? Okay. Remember your slope formula? Your slope formula. What is slope? Rise over run. So y2 minus y1 over x2 minus x1. Okay, what is our slope for DE? What's that? Well, let's do OC first, actually. What's our slope for OC? 0. Rise. It didn't rise at all. 0 minus 0 over 2s minus 0. So our slope is 0. Agreed? Okay. Well, we know that this is half the distance. So where is D going to be located? 1/2 R, 1/2 T, you said? So this is, if this is R, you want this to be, or if this is 2R, you want this to be R, and this to be T, because it went T, T.
Oh.
Is that what you want?
Yeah, that's what I kind of meant. So, go by the midpoints.
Go by the midpoints.
1R, 2R.
We want to find the midpoint.
So
You can't just say this. This isn't going to be right.
that's going to be 1R, 1T.
Do you remember how to find your midpoints? How do we find our midpoints? There's a fancy formula from earlier this year.
Oh, it was,
X1 plus X2 over 2. Y1 plus Y2 over 2. Remember that?
yes.
Okay, so what is our point here? X1 plus X2 divided by 2 is R. Y1 plus Y2 divided by 2 is D. That time it worked. Great. What about E? The midpoint of this one. So X1 plus X2 divided by 2 is 2R plus 2S divided by 2. I'm gonna write this over here just because I circled here.
So it'd
It's gonna
be
be r plus s for the x-coordinate, and the y-coordinate is t. So our slope here is going to be t minus t over r minus r plus s, which equals 0. And what do we know about parallel lines? They never cross, but what do we know about their slopes?
they're the same.
They're the same. Are their slopes the same? That part's proved. Okay, so any mid-segment, you can put it in your coordinate plane and show that they're parallel.
Okay, that makes more sense.
Okay, so we could have had this thing turned around, still put it in our coordinate plane. You can move it around however you want to, put it in your coordinate plane, use the variables, prove that they're parallel. It's kind of cool, right?
Oh, it's kind of easier.
Kind of cool, a little cool. A lot harder than yesterday.
Well, once you understand it, yeah.
Told you it was going to be a lot harder than yesterday. Yesterday was easy compared to this stuff. Okay? We'll scroll down a little bit. Give them so now we want to prove that this is half the length of this. Okay? We know all the points. We know our distance formula. We need the distance formula for OC. What is the distance of OC, the length of OC?
0. Or 2s.
Yes, we put it on our coordinate plane so we can just look at it. Right? Y didn't change at all, so we went from 0, we went over 2s, and that's where we stopped. So if we do this right, DE should equal 1s. Right? Distance of DE, square root of a bunch of stuff. x2 minus x1. What is x2 minus x1? R plus s minus r squared. Or was y2 minus y1, t minus t. Looks ugly, right? Bunch of letters, we don't know what they are. Well, t minus t, that cancels. R plus s minus r, r's cancel out, so we're left with the square root
Of s.
of s squared. What is the square root of s squared? S. Is that half the size?
Yes.
Yes. We showed that the mid-segment is half of the length of that opposite side. I know this part was really difficult and doesn't make a whole lot of sense immediately, right?
So you got homework?
No. That's as hard as it's going to be for the rest of the day. Mostly because you have your homework left and it's not that. It's not.
We're going to work on this more tomorrow.
We're going to do new things tomorrow.
Those new things are also Tucholke.
Yeah.
We have-
Are they gonna
we have- For this unit, we're going to have medians, mid-segments, altitudes, perpendicular bisectors, angle bisectors, and we're going to talk about all the ones we haven't talked about today, tomorrow.
So that means that everything after that is just gonna be all mixed together.
And you have to make sure you can figure out which one's which.
Okay, I kind of
Okay.
understand this.
This
This is a lot of
proof,
work.
yeah, this proof is way harder than anything else you'll see this chapter. Okay?
You should start off with an easy group.
We did yesterday, you were coming.
Yesterday was really.
Yeah, it's on the brown sheet in the back. Okay? Did anybody have any questions about this?
No, I.
Are any of you
kinda-
secretly cursing my name? Any of you not so secretly cursing my name?
Well, I have a question. Okay, so
Okay.
like for DE, do you use? Okay, never
We
mind.
use the
I got it.
distance formula.
Yes. No, but DES, I got it. That was my question. Like, where are you getting? I understand this now.
We used these ordered pairs that we came up with. Does everybody understand why I picked 2S, 2R, 2T instead of just SRT?
Yes.
Because you could use SRT, but then these would have really ugly fractions that you're squaring, and no one wants that. Okay? The rest of the time is yours to work on your homework. It's a worksheet that's part of your packet.
What is it?